Hi everybody, I am Dr. Pravin Kumar, HR, consultant gastroenterologist at St. Philomena's Hospital, Bengaluru. I'll be talking about astronomy. Astronomy started when the primitive man looked at the sky and wondered what is there in the top. Then he started joining the stars with an imaginary line and making characters and animal pictures and naming them in the name of the constellation. That gave rise to origin of different constellation like Canis means dog, Canis major, Canis minor, Pegasus, Sirius, multiple constellations, and they made the picture out of constellation. And this astronomy also helps us to locate where we are standing in the earth. In the olden days, sailors they used to look at the North Star and see it as a north direction. Then they used to locate the south, east, and west. Then they find out the way they have to travel. Later on, with the development of the sextant, they could actually pinpoint where they are on the earth by measuring the longitude and latitude, and they can exactly tell where they are standing on the earth. Further, man wanted to see more, then he developed telescopes and binoculars. Frequently asked question to me is that what a telescope my daughter or son should buy. He want to see. I remember my head of the department when we went to him and asked him which stethoscope to buy to put on the ears. His answer was, it is not the instrument which you put on the ear is important. It's actually the thing in between the ear, the brain is very important. Unless we know the place and position of the stars and constellation, we'll not able to see them. The best thing is to have the star charts, or there is an application called Star Map in the Android store. Download it and direct it at any glowing object in the sky. It will tell what is this. It's a planet, star, or it's a whatever thing. Or if you want to search something like an Andromeda galaxy, you just type and search and show it to the sky, and it will direct your mobile where you should move your mobile and where is that Andromeda galaxy is. It's very easy because of the app. Now, binoculars are different types, and this is the picture of the moon which you see through binocular. This picture we cannot see with the naked eye. This is the picture of the moon with the craters. Now, this is the picture of the Andromeda galaxy. This is the Andromeda galaxy seen by a binocular, which is 7 by 50, and this is 10 by 50 resolution binocular. For the beginner, it is always better to buy a lighter binocular. Don't buy a telescope in the beginning. Always better to buy a binocular. The binocular, this is the telescope uh, invented by Galileo. He made lot of observation and lot of literature. But the problem is that Galileo used a refractory telescope, and refractory telescope led to chromatic aberration and lot of colors when we see the object. Now, then the Newton invented the Newtonian telescope, which is a reflective telescope. They used a reflective mirror which reflected the light on the secondary mirror, then that could be seen through the eyepiece. And all the telescopes in the world's big observatory, including Hubble telescope, they are all reflective telescopes. And these are the different reflective telescope, Cassegrain, Newtonian, and others. Now, the thing, if you put a camera and put a telescope and take a picture, the stars look like this because Earth is moving. Then you require something called a mount and a motorable mount. This moves the binocular or telescope along with the movement of the earth so that you can stack the picture and expose it for longer hours and take a picture like this. You want a motorable mount. This is the observatory where they professionals see the sky and take pictures, and the mirror in such telescopes are huge. You can see a man standing beside the mirror, the size of a man compare the mirror, and the picture they take is magnificent. This is a picture of a nebula, and this is picture of a galaxy called Whirlpool Galaxy, and this is again a picture of a nebula, and this is again a crab nebula. This is a star which is blasted off. The problem with the telescope in the earth is that when you look, this is the sunrise. When you focus on the sunrise, you see a distorted picture like this because of the atmosphere which acts as a lens and distort the image. And the light waves are straight above the atmosphere. When it comes to the telescope, it gets distorted. Now, what is the plan? You keep a telescope in the sky above the atmosphere. Then came the Hubble telescope. This Hubble telescope is above the atmosphere and it gets images of stars and planets without distortion of the atmosphere. And this is the Hubble telescope in the space. You see the mirror of the Hubble telescope. It's very big compared to the comparison man is there. This is 2.4 meters diameter. And what happened was they then saw an empty patch in the sky as seen by the observatory on the earth, and they focused the Hubble telescope on that empty patch, and after 100 hours of exposure they got this picture. You see, each dot in this picture is a galaxy. Each pixel is a galaxy. Thousands, lakhs of galaxies are here. You know how big is one galaxy? Our Milky Way galaxy is so big. For the light to travel from one end to the other end, it takes almost 120,000 years. The light travels at the speed of 3 lakh kilometer per second, and it takes 120,000 years. It's so big, and so many lakhs of galaxies are here in a patch which is empty with the telescope seen from the earth. See how minuscule we are. And this is the history of the universe. 13.8 billion years back, whatever we see in the universe was so smaller than a pin of head of the tip of the pin. It is so small, it's so smaller than the tip of the pin. And then happened the Big Bang. And within 10 to the power of minus 32 seconds, that is trillionth of a fraction of a second, so minuscule of small time, it enlarged into 50% of the size what we are have present time. And it was dark. Initial universe was very dark. There was no light. After about 380,000 after the Big Bang, the light escaped and there was light everywhere. Therefore the previous period is called the Dark Ages. And what does the telescope do? Actually, telescope looks into the past. If you see a star, if they say it is 50 million light years away, actually you are seeing a star which was state of the star which was 50 million years back. Now, if the star blasts off now, you can see that blast off after about 50 million years. After later, 50 million years later, you see that picture of blast of the star. The Hubble can see past till 480 million years after the Big Bang. Now, in the future, they are planning to launch a telescope called James Webb Telescope, which can see still deep, 20 times more before than the Hubble telescope. What is this James Webb Telescope? It's a big telescope. Actually, it's an multi-segment mirror. It's an infrared telescope which will be placed at a Lagrangian point. That point is actually gravitational neutral point, and this will be a cooled telescope, and it is covered by an umbrella to prevent it from the sunlight so that it should not get heated up. Now compare the size of the mirror of the James Webb telescope with that Hubble telescope. It's so big. We are all in a hurry to see the picture from the James Webb telescope. We are all enthusiastic to see the picture from the James Webb telescope. Now coming to the astrophysics. Now the death of a star. So this is what is called as punarapi jananam, punarapi maranam. First start with the death, because death is the one which causes the recycling. Whenever the star dies, if the mass is very small, it becomes what is called as a white dwarf. Like our sun is a small star. Then if it's a large star, maybe 20 times more larger than the sun, then it becomes a red supergiant, supernova. Then either it becomes a neutron star or a black hole. And uh, this is what is the supernova. This is the real picture of the supernova, and this is the real picture of the black hole, which was taken an year back. To take this picture of the black hole, what they did was they made Earth-size telescope. How they made it? They kept telescope in different parts of the world, and they focused at a part where they thought there is a black hole, and they collected all the data, and they brought it to one place, and they joined all the data, and they to got this picture of the black hole. It is an imaging the elephant different with the tail, trunk, leg, and join the picture to make the picture of an elephant. And what is this black hole? This is a strange beast. It is a gravitational giant where even light cannot escape. Therefore, it is called black hole. And this black hole, what happens? There is a black hole is surrounded by what is called as accretion disk. What is this accretion disk? This accretion disk actually is a disk where the stars come and they are crushed by the gravity of the black hole, and they are eaten by the black hole. This is like the Lord Krishna shows his uh, Vishwarupa to Arjuna, where the Lord has opened his eyes and eating all the creatures, horses, everything, and it's going into his mouth and getting crushed. That's a picture of the black hole. And this is something called a photon ring. This photon ring, if you go and if possible, I don't think it's possible. If you can stand at a photon ring, you can see your back, because what happens, whatever light reflected from your back will come in a circle and fall in your eyes. You can see your back. And also they say that if you can enter the black hole and survey, you can see the past, future. You can become a Trikala Jnani, as shown in a movie called Interstellar. Now, this is what is called a gravitational lensing. What is this gravitational lensing? What happens is, this is the Earth, and we have kept a telescope, and this is some structure in the sky. And whenever we take the picture, what happens, because of lot of galaxies, lot of matter in between this quasar or star, in between the telescope, this gravity actually bends the light. It will not allow the light to travel in a straight line. It actually bends the light in an arc, and actually it, what we say, it bends the space and time. It actually bends the time also. What happens? This is what is called Einstein cross. Actually, at the center there is a quasar, and this is a single thing, but it is seen as a cross, four quasars. How? Because this is a quasar, because of the matter in between, it is not allowing the light to travel through here. It is bending the light in the arc, leading to uh, picture of the Einstein cross from the telescope placed in the Earth. Now, The supernova. The last naked eye supernova was seen in 1984. What is supernova? As I told, this is a star which blasted off, and whatever we wear, the gold, heavy metals, they are all formed in the supernova. If you are wearing a gold ring or gold chain, you be happy because these are the metals made in the supernova blast. And this supernova was seen in 1984, and from that they have captured the picture of the supernova. See, this is the picture seen in 1994, and this is in 2003. Just for comparison, you see here, this is the brightest center, and in 1994, the brighter part has gone into the periphery in 2016. That means it has taken 22 years from for traveling from here to the periphery. That means at the speed of light, that is 3 lakh kilometer per second, it has taken the light to travel from the center to the periphery. Imagine how big is this supernova. Now we talked about the death of the star, how the star blasts off, either it forms a supernova, black hole, or the small star forms the white dwarf. Now look at here. This is the hydrogen gas in the universe. This is they are the called nebula. This nebula forms the cradle of the stars. You can see this tiny formation of the stars. Whenever there is a gas, because of the gravity, the gas is attracted at the center, and this gas forms the star. These nebula are called the cradle of stars. There is a Orion Nebula. That nebula can be seen with the simple binocular or simple telescope. You can see the Orion Nebula, and this is a picture of the picture taken by the Hubble telescope. This is called pillar of creation. This is again a nebula. These are all the gas, and you can see the star formation in this nebula. Therefore, this is named as pillars of creation. This picture is taken by the Hubble telescope. This why astronomy? Uh, we always work with the patient, and always we are in the clinical work. Sometimes, if you develop a hobby like astronomy, it's like a relaxation. Actually, astronomy is comparatively easy. This astronomy is not as difficult as the medical field. Here in the astronomy, 1 is to 1 is always 2, and 5 minus 3 is always 2. And but in our medical field, 1 plus 1 cannot be 2. It can be 0, it can be minus 2, it can be minus 5. It's very difficult. It's not a pure science, but astronomy is very easy. If you develop a hobby like an astronomy, it's a very good relaxation for the doctors. Thank you all for patience hearing.